Good morning. We are on lesson 17. We only have two lessons left for the year, 17 and 18, which are law of sines and law of cosines. So we're still working with trig, but these last two, they're both formulas. These last two formulas allow us to work with triangles that are not right angles. So all of the trig that we've done up to this point, the triangle has had to be a right triangle, and now these last two allow us to work with any triangle. So law of sines is much faster, much shorter, and easier to remember. So we'll do 1 in 17. We'll do law of cosines in 18. When possible, you want to do law of sines because it's, like I said, shorter and easier. If it doesn't work, and I'll show you how to tell if it works or not. If law of sines doesn't work, then you have to use cosines. But cosines is like last-ditch effort. We want to try to use law of sines. So we're going to set up a proportion to solve. We need any two of these. Sometimes you'll see them written the other way. So sometimes you'll see like sine over a equals sine. It doesn't matter. It doesn't matter. We're going to set up a proportion and cross multiply. So it doesn't matter which is on top and which is in the denominator. So remember that capitals refer to angles. The capital letters refer to angles and the lowercase refer to sides. And that, I'm going to try to, the sides and the angles are across from each other. So let's say we have a triangle, ABC. Okay, so the capitals are the angles. Side A, lowercase a, is across from angle A. So the angle and the side that correspond are opposite each other. So this would be side A, which is across from angle A. Angle C is across from side C, and angle B is across from side B. So that is super important. It will throw everything off if you mix up the sides and angles. So we need at least one corresponding side and angle to be able to use law of sines. So those two go together. You have to have, I don't know why that popped up there. You have to have one set of corresponding sides and angles in order to be able to use law of sines. Solve the triangle means find everything. So make sure that you need to have all the sides, you need to have all the angles. This one already has all three angles. We already know that. So we need to find the other two sides. And we're just going to do one at a time. So it's basically two problems in one. So pick which one you want to find first. I'm going to find T over here. That's lowercase t is the side, which goes across from angle T. So the law of sines, you do a side. So let's start with the one we know, 20, divided by sine of the corresponding angle. Corresponding angle is 40. Equals, now we're going to do it with another one. So let's say we're going to do T over here. So T divided by sine of the corresponding angle, sine of 91 degrees. So when we have two equal fractions, we can cross multiply. And that means that if I multiply the two diagonals, so this diagonal we multiply, that is T times sine of 40. It is equal to the other diagonal. So I can multiply this diagonal, 20 times sine of 91, and they are equal. That's a way to get rid of the fraction. And we're solving for t. I'm trying to find the length of that side. So I need to divide by sine of 40. And then divide by the other side by sine of 40. So something over itself is 1. Sine of 40 over sine of 40 is 1. So I just have 1t, t equals, and then just be careful, but you're going to enter that whole thing into your calculator. If you just have a regular old scientific calculator, it will be better. So we get 31.1. You might want to, at some point in these notes, double check and make sure that you get the same thing using your calculator. Just check your parentheses and trig stuff. Okay, so this side is 31.1. I didn't tell you what to round to, so you could have rounded to whichever you like. Now we need to find the other side, r. So I'm going to always go back to the two original ones that I knew. I'm never going to go, well, I shouldn't say that. I'm going to try to avoid using the one that I found and rounded. So I want to use this same one again. 20 divided by sine of its corresponding angle equals, now I'm solving for r, divided by sine of its corresponding angle, which is 49. So divided by sine of 49. Again, I'm going to cross multiply. So multiply r times sine of 40 equals, and then multiply the other diagonal, 20 times sine of 49. And then divide by sine of 40 to solve. So sine 40 divided by sine 40, that's 1t, I did it again, 1t equals, the other side you're going to use your calculator to evaluate, and I got 23.5. Okay. So example 2, another solve the triangle, right? We have a problem though, because I have angle E, but not side E. I have angle F, but corresponding side F, I don't know. And I have, this is side D, but I don't have its corresponding angle. So I don't have those two that go together, which I have to use law of sines. So sometimes that means you would have to switch to law of cosine. In this one, though, we already know two of the angles of a triangle, and I know that a triangle, the angles add to 180. So 180 minus 141 minus 23 is 16 degrees. So I do have enough information to get that other corresponding angle. So now I have that pair, that corresponding pair of angle and side. That is enough to do law of sines. So it'd be a great place to pause and see how you do on this and see if you can solve for E and F. Okay, so I'm going to do a side, the one that I know. 9 divided by sine of its corresponding angle is 16 equals, pick which one you want to solve first. We're going to have to do both of them, so it really doesn't matter. Let's do E divided by sine of its corresponding angle is 141. So we set up our proportion and then cross multiply. 9, let's do the E first because I like it in front. E times sine of 16 equals 9 times sine of 141. We multiply the two diagonals and set them equal to each other. That's how we solve a proportion, which is two equal fractions, and then divide by sine of 16. So I get E is equal to 20.5, using my calculator to evaluate that. We need to do F still. So remember, I'm not going to use the 20.5. I'm not going to use the one that I rounded to get, if at all possible. I'm going to go back to the original two that I knew exact answers for. So 9, we're solving for F now. 9 over sine of 16 degrees is equal to F divided by its angle is 23, so sine of 23. So when I cross multiply, F times sine of 16 equals the other diagonal, 9 times sine of 23, and then divide by sine of 16 to get that F alone. F equals all of this entered into your calculator. Remember, at some point, you need to double check and make sure that you're getting the same answers that I am so that you're entering it into your calculator correctly before quiz time. 12.8. So that was solving for sides. We can also use law of sines to solve for angles. So in this one, we're solving for angle P. We're going to set it up exactly the same. So here we go with that corresponding side and angle that we need to have. So 34 is the side. Sorry, I wrote a 6. Divided by sine of its corresponding angle is 78 equals, this time I know the side. That's lowercase p is the side. So p is 18. I know that. Divided by sine, it's the angle that I don't know this time. I don't know its corresponding angle, so that's my variable. I'm just going to put p right there. So setting it up is exactly the same. We're going to cross multiply the same way that we did before. So 34 times sine of p equals 18 times sine of 78. We're solving for p, so I want to get rid of the 34 first. So I'm going to divide by 34 on both sides. So I get sine of p equals that big fraction. You can put this in your calculator and get a decimal now. Just don't round it to like the nearest tenth. Otherwise, you're going to get a little bit off. So you want to leave it all the decimal places. Do you remember if we have sine of a variable and we're trying to solve for that variable, do you remember how to get rid of sine? What's the opposite of sine? Opposite of sine is inverse sine. So if I do inverse sine and sine, they undo each other. They're inverses. So what one does, the other one undoes. And then I'm left with p. But if I do it on one side, then I have to keep my equation balanced and also do it on the other side. So you can enter this whole thing, inverse sine of that whole thing on many of the calculators, or you can turn this into a decimal. Like I said, keep all those decimal places, like point whatever. Don't round to the 10th. And do that whole thing. So this was 0.51784, like I literally have 10 decimal places. And then I did inverse sine. And I get 31.2 degrees. Always look at it, make sure that it's reasonable. Remember, we're working with triangles. So if you had gotten like 190, probably not going to be right because a triangle can only add to 180. If you got a negative, that doesn't make sense for a triangle. So make sure that your answer is reasonable. One last one, and this one's just like we did at the beginning, or the second problem we did. Find the perimeter. So it's just another way to say solve it. Find the sides. I need to know these other two sides so that I can add the 3 together to find the perimeter. So here's a corresponding angle side pair. That's what I need. So side divided by sine of its angle equals, let's find D. D divided by sine of, we don't have its angle, but we do have the other two, and it's a triangle. So if we subtract these two from 180, then that leaves 121 for this one. So sine of 121. So we set up our proportion. We cross multiply. D times sine of 19 equals 16 sine of 121. And then to get D isolated, we're going to divide by sine of 19. So D equals 42.1. Again, if you haven't yet, try to see if you can find E. This would be good practice. So my first fraction, I keep the same, 16 over sine of 19 equals E over sine of angle E is 40. So we cross multiply. And divide. So then the final part, find the perimeter. That means add all 3 of the sides together. So 16 plus 31.6 plus 42.1. The perimeter is 89.3.